Gen AI is revolutionizing the way we interact with the digital world, transforming businesses, streamlining processes, and supercharging productivity. Whether you are a tech enthusiast, a business owner, or just someone curious about how artificial intelligence is reshaping our world, staying ahead of the curve is more important than ever. In this video, I'm going to break down top 10 essential Gen AI terms that everyone needs to know today. Understanding these key concepts isn't just for data scientists or developers anymore. It's for anyone who wants to keep up with the rapid advancements in AI and how it's impacting industries across the globe. Hi, everyone. To those who are new to this channel, welcome. I'm Mihir Gandhi. I am an AI engineer at BlackRock, world's largest asset manager, where I help build AI powered platforms that transform how we interact with data and the financial markets. If you're curious about how AI is transforming the world, you're in the right place. Let's dive in and equip you with the knowledge to navigate the future of technology. So let's start with term number one, Gen AI or generative AI. Gen AI refers to AI models that create new content based on patterns they have learned from data. Unlike traditional AI, which classifies or analyzes data, generative AI can produce entirely new text, images, music, or even code. For instance, tools like ChatGPT can write articles or stories, while DALL-E can create images from simple text descriptions. Our second term is large language models or LLMs. These are AI models that can understand and generate human-like text. They are trained on massive data sets and learn language patterns from billions and billions of sentences. GPT-4 is a popular example. What makes LLMs special is their ability to handle complex tasks like writing code, answering questions, or translating languages, all without being explicitly programmed to do these tasks, which is super powerful. The third term is tokenization. Tokenization is how AI models break down text into smaller pieces called tokens. These tokens could be words, subwords, or even individual letters. For example, the sentence AI is awesome might be split into three tokens: AI is and awesome. The fourth, and one of the most important, embedding. Once the text is tokenized, each token is transformed into an embedding, which is a numerical representation that encodes both the meaning and context of the token. Think of embeddings as vectors that map words into a high dimensional space where similar words are located closer together. This allows the model to capture semantic relationships between these words, such as synonyms, antonyms, or context specific meanings. So, words with similar meanings or contexts are expected to have similar vector representations. For instance, the vectors for cat and dog are close together, reflecting their semantic relationship. On the other hand, the vectors for happy and sad are quite further apart, indicating their contrasting meaning. The fifth one is prompt. A prompt is simply the input you give to an AI model to generate a response. It's the question or instruction you provide. For example, you could ask, "What is quantum physics?" And the AI generates a detailed explanation. This segues us into prompt engineering. Prompt engineering is about designing effective prompts to get the best possible output from an AI model. Since AI models rely on the input they receive, crafting prompts that are clear, specific, and structured can drastically improve the quality of the response. A good prompt has three characteristics: clarity, context, which is the details, and a clear goal. Let's look at how we can improve a prompt by prompt engineering. We start with a simple prompt. Tell me about the stock market. This prompt is vague, it lacks context, and can lead to a very broad and unfocused response. We can improve this in the following way. We can ask, can you provide a summary of the current trends in the US stock market for technology companies, including major companies like Apple, Microsoft, and Google? As we can immediately see, this is more specific as we have terms like the US stock market and the technology companies. It has more context, such as the current trends, and is task oriented or has a clear goal, which is to provide a summary. This improved prompt will definitely give you a better response as compared to the first vague prompt. So the next time you write a prompt, make sure you keep these characteristics in your mind. Let's move on to the next term, which is zero shot and few shot prompting. In zero shot prompting, the model is asked to perform a task it hasn't been explicitly trained on without providing any examples or context in the prompt. The model relies solely on its pre trained knowledge. On the other hand, in few shot prompting, the model is given a few examples within the prompt to help guide its understanding of the task. Now let's move on to our next term, which is somewhat advanced but super powerful: retrieval augmented generation, or RAG. RAG enhances response accuracy by combining two steps: retrieval and generation. So, first, it creates embeddings of the input query. It then compares these embeddings with the document embeddings from a large set of documents using a similarity measurement like cosine similarity to find the most relevant documents. Then, a generative model uses both the query and the retrieved documents to generate a coherent, fact based response, grounding it in real time for better accuracy. So instead of just relying on its billions and billions of sentences that it learned, you can pass specific pieces of information that are related to the query from your documents. Let's try to understand retrieval augmented generation with a simple exercise. Imagine you are in a library surrounded by hundreds and thousands of books, and you need to find the answer to the question: who said happiness can be found even in the darkest of times when one only remembers to turn on the light? Now, some of you who are huge Harry Potter fans might already know the answer to this, but let's say you don't. This task is super challenging when you have hundreds and thousands of books and you need to go through each and every one of them to find the answer to this. That's what happens with an LLM when there is no RAG. It has to go through all of its learned knowledge to find the answer to this question. Now, imagine someone brings you a set of 5 or 10 pages and tells you that the answer to the question lies in these 10 pages. How simple is the task now? That's what happens when an LLM is combined with a RAG. Instead of going through all of its knowledge base, it can use this retrieved chunks of information to base its answer off, and thus its accuracy is often improved. If you know the answer to the question, please drop it down in the comment. I would love to see how many Harry Potter fans we have here. This next term is something that you would hear people saying over and over: LLMs hallucinate. This ChatGPT is hallucinating on my query. So, what does it mean? Hallucination refers to a model generating information that seems plausible, but is actually false or not based on any factual data. This happens when the model confidently produces content that isn't grounded in its training data or real world facts. For example, you might ask the question: who is the first human to walk on Mars? And the LLM might respond: John Doe was the first human to walk on Mars in 2025. Well, that's not true. I mean, it can be, but at this moment it's not. And on to our last and the 10th term, which is fine tuning. Fine tuning is a process of adapting a pre trained model to perform better on a specific task. By training the model on a smaller task specific dataset, it becomes more accurate in generating responses relevant to that domain. So this is super common in fields like healthcare, law, finance, where you take a general LLM, which is trained on all sorts of data, and you supplement it with domain specific data to make it more powerful and accurate in that specific domain. Let's understand fine tuning with the help of this simple example. Building an LLM from scratch is like making pasta from scratch. You need to boil the spaghetti, you need to cut tomatoes, you need to have onions, garlic, oregano, so on and so forth. And then you need to actually make it. As you can imagine, this is a time consuming and expensive process, and not everyone can do it well. On the other hand, fine tuning an LLM is like someone else preparing the pasta for you, and then you just tweak it a little based on your preferences, like adding some more cheese, adding some more oregano, olive oil, and so on. And there you have it, 10 essential Gen AI terms that are commonly used in the world of AI today. From tokenization and embedding to fine tuning and RAG, understanding these concepts is key to staying ahead in the AI revolution. If you found this video helpful, don't forget to like, subscribe, and hit that bell icon and do all of that good stuff. More importantly, let me know in the comments if you found this useful or if there's anything specific you'd like to learn in the next video. Thanks for watching, and I'll see you next time.